Do you think there's life on Venus? You know, nowadays we usually look for signs of life on Mars. But in the 1960s, the planet we actually expected to find life on wasn't Mars. It was Venus. Because Venus is the planet in our solar system that resembles Earth the most. So much so that we call it Earth's twin. For example, Venus is only about 20% smaller than Earth. In terms of proximity to the Sun, Venus is second and Earth is third. Both are rocky planets, and both have significant atmospheres. And very likely, Venus once had oceans on its surface, just like ours. But unfortunately, Venus's similarity to Earth ends there. If we took you, happily living on Earth's surface, and placed you on Venus's surface, it would be the most terrifying, awful experience of your life. Venus's atmosphere is suffocating, thick, and covered with relentless clouds of sulfuric acid. The air is filled with gases, mostly carbon dioxide, that are extremely toxic to life as we know it. Even so, it does rain on Venus. But there's a catch. These aren't romantic rains like we have here. Because what falls isn't liquid water. It's sulfuric acid. This acid, which can be as strong as the acid in your stomach, corrodes everything it touches. Thankfully, these rains evaporate before reaching the surface and return to the atmosphere. But still, I think you can imagine how terrifying that environment is. Plus, the pressure on the surface is so intense that before you could even take a breath of that suffocating air, you'd be crushed like a soda can run over by a bulldozer. Think of it this way. The pressure on Venus's surface is around 90 atmospheres. That's equivalent to the pressure you'd experience nearly a kilometer deep in one of Earth's oceans. Honestly, I don't know which is worse, being crushed by that pressure or having your skin scorched off. Because temperatures on Venus's surface are around 470 degrees Celsius. That's hot enough to melt lead. And the heat causing those temperatures has nowhere to escape. So, in short, Venus might look beautiful from the outside, but in reality, it's a complete hellscape. But here's the thing, Venus wasn't always like this. Formed from the same solar nebula, the same cloud of gas and dust as Earth, about 4.5 billion years ago, Venus, due to its proximity and similarity to our planet, likely had conditions comparable to Earth's billions of years ago. According to analyses, Venus may have had oceans on its surface for an absurdly long time, perhaps as long as 2 billion years. That's more than enough time for bacterial life, or even more complex life, to evolve. The valleys and ridges we see on its surface today are thought to have been shaped by those waters and potentially even by past earthquakes and volcanoes. Tectonic activity that's essential for life. These are all prerequisites for life. But something went terribly wrong on Venus at some point. Maybe it lost its magnetic field during a powerful solar storm due to its proximity to the Sun. Or perhaps Jupiter knocked it out of its original orbit. We don't know. But for some reason, because of its closeness to the Sun, it started being affected even more by the solar radiation it already received in greater amounts than Earth. This radiation rapidly evaporated those oceans on its surface. Water vapor, being a greenhouse gas like methane and carbon dioxide, caused an abnormal buildup of heat on the planet's surface. And that's when the hellish temperatures we see today began to form. Those temperatures evaporated the surface water even faster. As that water vapor was pummeled by the scorching sun, it split into hydrogen and oxygen. The hydrogen escaped Venus's gravity, and drifted into space. The oxygen left behind reacted with gases like carbon dioxide and sulfur dioxide, spewed out by Venus's then active volcanoes, forming those sulfuric acid rains we mentioned. Since this acid is highly reflective, it bounces back the sun's rays, halting the temperature increase and creating a thermal equilibrium on Venus. Alas, that equilibrium settled at a point so awful that life as we know it couldn't survive. If life ever evolved on Venus, it was likely wiped out entirely by this point. So, if you want to see the real destruction that greenhouse gases, which are increasing on Earth and unfortunately disrupting our seasons, can cause, look no further than Venus. Venus shows us a potential future for Earth. By the way, we know so much about what Venus is like because we've managed to land probes on its surface multiple times. To date, 46 missions have aimed to reach Venus's surface, and depending on your criteria for success, 10 to 15 of them succeeded. I say it like that because we didn't always know how awful Venus's environment was. Early probes disintegrated before even making it through the atmosphere. But despite that, they managed to send us invaluable data, especially the famous Venera missions sent by the Soviet Union in the 1960s. They sent us data first from the atmosphere and eventually from the surface after landing intact. So, our knowledge of Venus doesn't just come from indirect sources. We know what it's like down there. Take a look at these photos. They were taken by missions that landed on Venus's surface. But Venus is such a hellscape that the electronic circuits of these probes could only withstand the environment for a maximum of 127 minutes. Then they broke down. But that time was enough to capture sounds and images from the surface. Listen. So, when you consider Venus's conditions, it's not that surprising that attention eventually shifted to Mars. Though Mars isn't exactly a bed of roses either, still, scientists concluded that finding any form of life on Venus was impossible and chose to focus entirely on Mars. But visionaries like Carl Sagan didn't think Venus should be abandoned so easily. Mars research is, of course, important. But according to Sagan, it shouldn't come at the cost of completely abandoning Venus. Because the missions to Venus sent back some critical data. Yes, the surface might have awful conditions, but the atmospheric layers you pass through before reaching it, particularly one notable section about 50 to 60 kilometers above the surface, have temperatures between 30 and 70 degrees Celsius and pressure conditions similar to Earth's surface, making them comparable to habitable zones on Earth. What if remnants of the life we suspect once existed on Venus's surface, especially microbial life, are still surviving in these still habitable atmospheric layers? If you think about it that way, Mars doesn't have any region offering that kind of possibility, and that makes Venus a very strong candidate. I know this might sound like a crazy idea at first, because we tend to believe that for life to exist, there need to be solid surfaces, like land or ocean floors. That's largely true, but bacteria and archaea that thrive in extreme conditions can live, grow, and reproduce inside liquid droplets suspended in the air. For example, I mentioned earlier that sulfuric acid rains evaporate before reaching the surface and rise back into the upper atmosphere. This kind of cycle could allow microorganisms to live continuously in the air. Plus, with abundant carbonyl sulfide, hydrogen sulfide, sulfur dioxide, and carbon dioxide up there, life might have evolved to survive using those gases. and those thick cloud layers likely protect them from the sun's harmful ultraviolet rays. All of this points to an incredible possibility. But, like any scientific possibility, it needs to be proven. We can do this in two ways. The first is by sending probes directly there to collect samples and bring them back to Earth for analysis. With the growing interest in space exploration today, there's been a slight uptick in Venus research, but we're still very much at the beginning. The Moon and Mars have captured so much attention that Venus studies always seem to stay in second or third place. As long as institutions like NASA continue to have limited budgets, this will unfortunately remain the case. That's the harsh reality of humanity. The second method, though, has the potential to change this unfortunate fate. If we can use indirect methods to find traces of life on Venus, or at least detect strong signs that life could exist there, then that incredible scientific possibility we mentioned would gain even more traction. And administrators at places like NASA, who allocate funds for the most promising results, might choose to dedicate more resources to Venus. To do that, we're not looking for life itself directly, but for chemical and physical signs, biosignatures that might suggest its presence. But for biosignatures to indicate life, they need to be specific enough. For example, we search for water on celestial bodies because water is a fundamental requirement for life. Naturally, finding water somewhere increases the chances of life being there. But while water is an important criterion for life, it doesn't carry meaningful evidence guaranteeing that life is already present. In fact, water is far more common in space than you might think. So, we need to find more distinctive biosignatures. One of those is phosphine, a gas that was announced to be present in large amounts on Venus in 2020. To briefly recap, phosphine can be produced in small amounts through high-energy, abiotic processes like volcanic activity, atmospheric events, and lightning. In gas giants like Jupiter and Saturn, rich in hydrogen, it forms in their extremely hot and high-pressure inner layers, rising to the upper atmosphere over time, where we can detect it remotely. But on rocky planets like Earth and Venus, there aren't environments conducive to that kind of formation. On Earth, however, phosphine is produced, especially in oxygen-free environments, when living organisms break down organic material. That's why discovering that this gas currently exists on Venus was incredibly exciting, especially considering it was detected not on the surface, but in that critical layer of the atmosphere between 40 and 80 kilometers up. Of course, the geological processes we think occurred on Venus in the past could have produced phosphine. After all, we know volcanic activity played a huge role in turning Venus into the awful planet it is today. The problem is that phosphine is an extremely unstable molecule. So it's impossible for phosphine produced by volcanic activity that ended millions of years ago to still be around today, especially not in amounts detectable from such a distance. That means we need to find a source that's continuously producing it. And we don't know of any abiotic source on Venus that could do that, which leaves us with the possibility that life is producing this phosphine. At least, that was the claim of the researchers who made the discovery. Other researchers aren't so sure, because we still know very little about Venus's geology and chemistry. There could be countless abiotic processes we don't yet understand that are continuously generating this gas. Plus, as we said, the phosphine detection wasn't done by physically collecting gas samples from Venus. At least, not yet. As sunlight passes through Venus's atmosphere, some of it is absorbed by the chemical components there, while some reflects back to us. Using telescopes on Earth, we capture those unabsorbed photons and use a method called spectroscopy to determine which frequencies were absorbed. Since we already know which chemicals cause specific changes to light, we can figure out what's in the planet's atmosphere. Of course, to do this, we rely on statistics and artificial intelligence methods to create mathematical models that best explain the data we collect. Other experts who reviewed the spectral data and the analysis published in Nature Astronomy in 2020 raised two main objections to the findings. First, they argued that other gases, like sulfur dioxide, which is abundant in Venus's atmosphere, could produce signals similar to those attributed to phosphine. In other words, the signal wasn't strong enough. Their second objection was that the mathematical model used to process this already weak data was loose enough to produce nearly any desired result. Dave Clements and his team, who discovered the phosphine on Venus, rolled up their sleeves to find more concrete evidence that would convince the scientific community even further. After 4 years of effort, they gathered 140 times more data than they had for that 2020 paper, proving not only that phosphine is indeed there and as abundant as they initially thought, but also detecting ammonia molecules, something that hadn't been definitively identified on Venus before. Ammonia isn't as strong a biosignature as phosphine, but it's also a molecule that breaks down easily. And since living organisms are often the most abundant producers of ammonia, its presence alongside phosphine significantly strengthens the possibility of something organic in Venus's atmosphere. How about that? Exciting, right? There you go. Is there life on Venus? We don't know. Of course, there could be other geological or chemical processes explaining these findings. We don't know. But one thing we know for sure, Venus, as Carl Sagan predicted, is one of our strongest candidates for finding traces of past life or even active life that might exist there today. It's not a planet that deserves to be sidelined.